Welcome. My name is Jeffrey Snover. I'm a partner architect with Microsoft and been working on PowerShell for a few years. Today we're going to talk about how to use PowerShell, in particular PowerShell version 2, to create manageable web services. By the way, just so I get a feel for my audience, how many of you are using PowerShell today? Yeah, oh, great. And okay, so I've got some intro material. I'll kind of just try and zoom through that, but you might want to just have maybe 5 minutes worth of coping with that. So I love web services, right? Web services are great because they force you to do the right thing. There's this great joke about, what do you call a boomerang that doesn't return? And the answer is you call it a stick. Right? So then you ask yourself the question, well, what do you call a web service that isn't manageable? Right? And that's called code. Right? Web services are all about manageability, right? Because it forces us as developers to think about the operational costs and how do I run this code? And boy, that's quite a different thing than just producing the code itself. So here I'm going to show you, how to help with that process. So when you develop in a web service, often you have to deal with issues like, boy, I want to deliver great management for this thing, right? Both in the cloud and outside the cloud, but I want to do it cheaply. Boy, writing a web service, writing any code is hard without having to deal with that management stuff. So I know I have to do it, but I like to do it really cheap and move on. Right? Then I've got a wide range of admins. Like, do I focus in on the beginning admins, the middle admins, the high-skilled admins? What do I do there? How do I satisfy the range of administrators? Then I want to be able to automate lots of stuff, and including heterogeneous stuff. So let me, at this point, get the focus here, right? So when I talk about web services, I'm talking about things running in the cloud. Okay, or anywhere, but in the cloud, and there you have to deal with managing everything, right? It's not just about your part of the stack, right? You got to be able to manage the hardware. You got to be able to manage heterogeneous devices, right? Whether they're network browsers or network devices or other operating systems. You got to deal with the operating system and then your code. And the point I want to make is that everything that we're talking about here in terms of web services apply to the enterprise case as well. It's exactly the same thing. Okay? Then, how do I safely enable end users to do their own management? One of the ways you drive automation costs down is by eliminating admins, okay? Which is to say that you let end users do a certain set of things by themselves. But good Lord, you don't want to give them admin privs, right? I mean, that would be a disaster. So in fact, what you want to do is you want to say, well, hey, this guy I trust, I'm going to give him a bunch of capabilities. You guys, not so much. I'm going to give you a subset. But how do you do that in a safe and effective way? And then how do I integrate into my customers' management systems, right? Our customers all have management systems today, whether it's System Center, Tivoli, HP, BMC, et cetera. And you have to be able to integrate into those things. So those are sort of the issues that PowerShell can help you deal with as you produce your software. So we're going to go over PowerShell version 1, quick overview of that. We'll then talk about some of the new stuff in version 2. And here, I've got to tell you, we're going to talk about a very, very thin sliver of PowerShell version 2. It turns out that PowerShell version 1 had some great architecture, and we were able to very quickly take that stuff and, there's this joke. Nobody cares about your first million lines of code, right? For often, you write all this code, and it just gets you to the point where you can start doing things, and then you have to ship it. But then you're poised to be able to go write 500 lines of code that stitches it together and produces something great. Ooh, another 1,000 lines of code, and you can do amazing things. So that's where we are with version 2. Version 2 has at least as much innovation in it as version 1 did because we were able to leverage all the great architecture work that we had done in version 1. So it's vast, and today I'm only going to be able to talk to you about a very narrow sliver of that. And in particular, we're going to talk about how you can manage, the entire stack, raw hardware, other operating systems. Then we'll talk about how you can focus in on managing a single machine in lots of different ways, and how you can take that and then scale up to manage large sets of machines. And then we'll talk about this idea of scalable remote administration, the ability to create an administrative surface and expose it out to the customers. All right, so for those of you who are not familiar with PowerShell, it's a command line interface and a scripting language. In fact, what it really is, it's an automation technology an automation technology that gets surfaced as a command line interface and as a scripting interface. So let's get this in focus. Set up this demo. Okay, what I'm going to describe is how to write a commandlet and what you get for writing the commandlet, right? Commandlets are the base class. You go and subclass a commandlet class, and you override a method called process record, and you do stuff. So here I'm just going to do process.getProcesses, returns a set of processes, and I write the object. That is as simple as you get as a commandlet. So then the question is, what do I get for that? Okay, let's build this. Okay, you build that. We'll then install it. That creates a snap-in. I now load that snap-in. And now I've got, by the way, did you notice what I did here? Here's my class. I say that its verb is get and its noun is proc. So then here I can say get command, get proc. By the way, can you see that in the back of the room? Yeah, okay. And you'll see, here's where it's implemented, implementing type, systems, blah, 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 blah. Okay, all the information. And what happens here, the way PowerShell works is you write a .NET class, you annotate it, and what you're doing with those annotations is you're defining the grammar for your commandlet. We extract that grammar, and then we project it through various things. We project it as an API, we project it as a command line interface, you'll see we project it as a web service. Okay? So now I can do things like I'll run get proc and get all the processes. Right? So again, why? Because I called get proc, it found this, and invoked this. You got all the processes, and you returned them. You wrote them through the pipe. We then take, PowerShell then takes that and takes those objects and turns it into a table and shows it to the user. But what you did was you emitted a set of objects. That gives us incredible power, right? So with those, what was it, 6, 8 lines of code? Now you can do things like, I'm going to get the processes where the handles are greater than 700, and I'm going to sort them by handles. Right? You didn't have to do any of that work. PowerShell did that work for you. Now here we'll go and we'll get the processes where the working set's greater than 5 megabytes. We'll group it by company and sort by count. Right? Pretty powerful stuff. And again, you don't have to do anything. PowerShell is doing that for you. Here we'll get the processes. We'll select the name, the company, the product description, and output it to a grid. Right? And so then you can sort this grid. You can say, hey, I'd like to show it in groups. Sorry. Oops. Nope. Went away. So you all that stuff, there's graphical stuff as well. So that's the basic value chain. Okay, now we'll go and make it a little more sophisticated. We'll add a parameters. Sorry. We'll add an attribute called, we add attribute parameter. We say it's position 0, say that it's mandatory, have a help message, and then say that you can accept the value for this parameter from the pipeline by property name. Now we'll just change this code to say get processes by name, Okay, we'll build that. Okay, gets them all. I think I get that wrong. I installed it wrong. Oh, I'm going to get flummoxed here. Anyway, say again? Oh, that's it. Thank you. Build that again. Give enough time and resources. There we go. Hoo-ha. Now when I run git proc, notice it now prompts me for this. Why? Because I said it was mandatory and I didn't give a value. So now it asks me this, and notice I can say bang question mark, and I get the help text that I put here, and then finally I can say, and get the object back. And notice also I said that it was, I said position 0. So whereas I could say minus name, well, let's say SS, I can also just use the positional parameter. Okay, so that's what's really going on behind the scenes with PowerShell. You write a .NET class, small .NET class, I don't know if you know it's a small .NET class. You annotate things, your parameters with attributes. We extract a grammar and we project it as stuff. That's the magic of PowerShell. And then there's a whole bunch of utilities, whole big ecosystem of folks that take your objects and do wonderful things with it. Now in version 2, you see how we do so much more with that. Okay? So the goal of version 2 is really quite straightforward. One is we want to make it easier to get and use and learn and master PowerShell. We want to make it easy to layer applications on top of PowerShell, right? It is Microsoft's strategy to layer all administrative GUIs on top of PowerShell. Okay? So you want to make that easy to do, whether it be rich GUIs, Silverlight GUIs, web GUIs, whatever. Workflow, everything on top of this. And then we want to be able to manage anything and everything. Okay? So whether that's clients, servers, web services, raw hardware, other operating systems, everything. One of the principles of PowerShell is that admins have to deal with the way the world is, not the way the world should be. So you're never going to hear from us, oh, you know, everything, you just dump everything that you've had in the past, do these things, and everything will be rosy. And that's not the way the world works. Admins have legacy stuff, they've got heterogeneous stuff, and they need tools to manage all of that. And that's what we're in the business of. And then using any mechanisms, okay? Whether it's WMI, .NET, in version 2 you see we add support to be able to access native code, web services, WSMan, so anything, anywhere, anytime. Really what we're moving towards is this idea of a universal automation environment, okay? An environment, so what's the distinction between an environment, a framework, a library? You ever think about that? Some people talk about frameworks, some people talk about libraries. Frameworks are down here at the bottom, right? Frameworks are things you plug into and you provide value to that framework. Libraries are APIs that you can call and they provide value to you. An environment is some that has both. So we have an API at the top. Our language calls that, our command line shell calls that, our integrated scripting environment calls that, admin GUIs call that. You can write your own application. Lots of folks are hosting PowerShell in their applications, so it's an API that you can call. That then talks to a runtime engine, and in version 2, that runtime engine can be in your process, it could be a local process, it can be a remote process, and you can have lots of them, okay? And then they call an automation framework. Automation frameworks are things that other people plug into, or you plug into. Standard ways to write commandlets, namespaces, and here what we're doing is we're trying to now standardize the interface. With commandlets, you can do anything. With namespaces, it's a standardized experience for dealing with hierarchical information. You'll see that what we want to do is to be able to, over time, have more and more standard ways to deal with standard things. So in version 2, we now have a standard way to deal with events, a standard way to deal with jobs, and a standard way to deal with transactions. All of these are automation frameworks, frameworks that you can plug into and then have standard ways to access. Okay? And by universal, what I mean is should be interactive or programmatic, work across a wide range of operating systems, work here, work there, work on lots of machines, work synchronously, asynchronously, be able to work with various authentication mechanisms, and then be able to access anything. And ultimately, at the scripting language, the idea of universal means that it works for all admins, simple beginning admins or very, very sophisticated admins. Okay? So the value proposition of this is, in version 1, you provided the commandlets and providers. PowerShell provided the CLI, API, the language with access to a bunch of good stuff, utilities. We had about 129 commands in version 1. The users then write simple or ad hoc scripts, sophisticated scripting, and then the community take those scripts and share it around, right? People are not going to be successful with PowerShell unless they leverage the community. Okay? By the way, a shout out to Keith Hill here. Keith is the maintainer of PowerShell Community Extensions, PSCX, at CodePlex. It's a great project. If you have not already found it, you should go find it and use it, contribute to it. It's great stuff. He's doing a lot of things that we weren't able to do in version 1. In version 2, we've done a bunch of them, but he'll then go and add more stuff to it. Now, in version 2, yeah, hoo-ha. Doing great stuff. Version 2, this value chain just gets better. You now have the ability to write commandlets in PowerShell itself. In version 1, you can only write PowerShell in a .NET language, C#, VB. Now you can write it in the scripting language itself. And you also have the ability to write transactional commandlets. Transactional commandlets, transactional providers. It's like freakish. It's great. In addition now, we'll take that stuff and we'll expose it as web services, workflows. The language gets richer. We get access to web services, unmanaged code, WSMan. The utilities get richer. We get job control, eventing, remote execution. We now have, in PowerShell itself, 241 commandlets. I think that's actually higher now. And in WS08 R2, there are over 570 commandlets. So lots of momentum. And we also now have a graphical scripting environment for people to be able to script and debug, create their scripts and debug their scripts. And version 2, you now get users can do systems programming and write these scripts across multiple machines. So it's a pretty great value proposition. And the key point I want to make here is that everything that you've done in version 1 works fine in version 2. Okay? Good stuff. So here's the thing. I've been waiting for this for a long time. So long. I'm just going to savor for a moment. So I don't know if you picked it up. Of course, PowerShell version 2 is in WS08 R2. But no surprises there, because PowerShell was in WS08. Okay? But now PowerShell's in the client. PowerShell version 2 will be in all versions of Windows installed by default. Yeah! There you go. Good things come to those who wait. But wait. It gets better. It gets better, because you're probably asking yourself, but what about PowerShell version 2 is going to be in Server Core. So lots of hard work to get this done by various teams, but you guys needed it, so we did it. Yay. Now, let's talk about managing all the stuff in your environment, right? You have to be able to manage raw hardware and other operating systems. You or your customers do, right? Depends on who's running things. The way we are going to do that is through WSMan. WSMan is a standard interface. WSMan stands for WS Management, Web Services Management. It's a standard driven out of the DMTF, and it's a way to talk to lots of great stuff, right? Other operating systems, raw hardware. If you buy a hardware device now, whether it's a laptop, desktop, server, chances are that we can talk to it using WS Management, right? In the hardware itself is an extension that even when the machine's off, it's listening on the NIC, and you can talk to that thing and do things like power it up. It's freakish. It's cool. You can have a raw hardware where there's nothing on it, and you can go get inventory information, hardware inventory information. So pretty cool stuff. Oh, well, here are the scenarios. So remote control, it's down, power it up. It's up, power it down. make it go to sleep. And again, you're talking to the hardware. Right? You're not talking to the OS. So the OS can be hung, if you're using somebody else's OS, and you can go say, hey, shut yourself down, and it'll do that. You can also control the boot sequence. You can do hardware and software inventory. Now, software inventory, oh, really? How does it do that? It's the software of the hardware, right? The firmware BIOS, the BIOS versions, that sort of stuff. You can get alerts. So you can say, hey, tell me about if you had any chassis opens. Somebody open up the chassis, that generates an alert. You can get at that. You can configure and manage the BIOS of these things. You can do software and firmware upgrades, and then do health monitoring. Monitor things like power consumption, voltage, all that. And you'll be able to do that all using PowerShell version 2. So let's show you a little bit of that. Now, sadly, I don't have a device that has that. Okay, but what I'm going to show you the next best thing. And the next best thing here we go. Here's a Linux machine running in a VPC. Okay. And what we're going to do is we're going to manage that thing. Set up the demo. Okay, so again, WSMan we use in the following scenarios. We use it to talk to raw hardware and other operating systems. It also is our way to be able to talk to Windows, WMI on Windows, through a firewall. Right? So you know that if you use WMI, it's great, awesome. It uses DCOM. And if you set up a firewall that doesn't allow DCOM to pass through, well, how do you talk to that device? And the answer is WS management. And then we also use it for PowerShell's native remoting. We have some streaming extensions to WS management that we use natively. So we are investing very, very heavily in WS management. So here are the types of commands that we have. Connect, disable. You see there's a pretty good list of commands we have to access WS management. Now we'll go see if a particular device talks to WSMan. We can do test it. And here we're talking to ourselves, so be clear about that. This is loopback, but it goes through the network stack to do it. And here we get a WSMan instance, and we'll enumerate the BIOS. Okay? Here we can enumerate the services, and I'll get it in a variable S. We'll just take a look at one of them. Okay? So now notice, it looks a little odd. Check out these three things. These things up here. What's with that? Right? Looks like an object, looks like a .NET object, but what's that stuff? And so then, let's take a look at it a little bit more. We'll explore the properties, and notice here, right? So first, you see, lots of great stuff. But even these members, right? Look at those, right? Select node, select single node. What's with that? Well, if you take a look, you'll see that we're leveraging PowerShell's synthetic type system, okay? Back earlier, I showed you a slide. I didn't really talk about it. I talked about these type normalizers. Well, when you deal with the world as it is, well, the world's a pretty confusing place. You've got various people saying, I am the truth and the light, and you just do it this way, right? It's .NET, or it's WMI, or it's ADSI, or it's ADO, or it's this, or it's that. Well, web services, they're one of them, and what they come back with is XML, right? Well, how are you going to deal with XML? Anybody program against XML? Yeah, all the people are not so happy, right? That's a horrible user experience, right? Programming against XML. And so what we do is we have these type normalizers, which basically say I can take these types and I can normalize it so that I project a user experience of that data type. So let's get that more in focus. Here, this is the type, this is the PowerShell view of this object. So you see it's the .NET type hierarchy, system, object XML, XML node, link node, XML element, but then we extend it, right, with this thing, it's XML element, and we put the type, right, the WS management type. Now, why is that interesting? Well, I'll show you. Here, let's take a look at 6 of these things, right? Blah, 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 blah. Oh my God. Nice, programmable, good stuff, but oh my heavens. Well, now, let's check this out. we'll bring up one of our formatting files, a formatting file. By the way, this is the integrated scripting environment. Ooh. WPF application, nice, visual debugging. You're going to love it. I mean, it rocks. Well, notice what this does, it's a view definition. We're a metadata-driven system, and here I'm saying I've got a view whose name is this, and I want to select this view by this type. So remember before, when we started, you just wrote get proc, right? You wrote the processes to the object, and it got this nice table. Well, how did that happen? And the answer is, somewhere off in metadata, someone said, if you ever see an object, which is a Win32 process, here's how you project it to the screen. So that's what we're doing with this file. We say, hey, if you ever see an object that looks like this, here's how you project it. And so what we're going to do is we're going to say, hey, make that thing into a table, give it these column headers, and grab these properties, name, start mode, state, description, right? Metadata driven. So now we'll go and update our format with that file, and we'll take a look at those objects again. Remember, just get it in focus. Here's hamburger A, and here is hamburger B. Magic of PowerShell. Magic of software. Right? So you can see this idea of we want to make people successful with dealing with the way the world is. Look, we're not going to go to the DMTF and say, just make everything a .NET object. Unix guys probably not so on board with that. Mono, yes, but maybe some of the others not so much. Certainly the hardware devices, right? They're not going to emit .NET objects. Well, I don't even know what that would mean. So they emit things, whatever they emit them, and then we take that and normalize it for your customers. Okay? Now remember, it's still a .NET object. So here, I'll get that object, get all of them. I'll say find the ones that match some regular expressions. I'll sort them by start mode, state, name. I'll format them, grouping things by state, name, state, and show the name, right? So again, this is XML that we're working on. So here are all the services that are auto start. These are the ones that are disabled, and here are the ones that are manual. So rich programming experience against XML. And of course, back to our great grid view. By the way, I don't know if I showed you this. So this is our grid view, out grid view. Okay? Take data, just output it out grid view, show it like this. Well, check this out. Net, work, right? So we're filtering, right? So in addition to sorting, right? So you could sort, of course, all that good stuff. But now you can also do things like filter, add a criteria, start mode, state. So you can say, I want the start mode that what? Contains, begins with, equals. Start mode that equals auto, and state that equals, well, let's just say run. Apply the criteria. That's interesting, but how about does not contain run? Well, that's interesting. So this is a mode. This is a service that's start mode is auto. It's supposed to be started, but its state says that it's not running, right? So notice we just got the objects and put it in an environment where you can manipulate it and party, party, party. All with XML. Okay, so now we talk, that was all talking to myself. Now we're going to talk to this Unix box. Let's see if I can get these credentials right. Okay, so now I wrote a helper file for this because when I talk to a Unix device, it's a little bit more complicated. And so here it's a utility. It's going to take the class I want, the computer name, and a credential. And then notice this great technique in version 2. I mean, this is like crazy, crazy, crazy powerful. It's called splatting. Pretty nice name, too. Okay? Splatting says, I'm going to create this hash table. Right? This is a hash table. And here are my entries. Right? Here's the computer name. Here's users, blah, blah, blah. Okay? Big, complex stuff. And then I run get instance, and I say $params. Notice that was the name of the hash table. But notice I didn't say $params. I said @params. Okay? And that's what's called splatting. And what that does is it takes the hash table and basically splats it on the command line, which is to say it's as though I took each one of those things and typed them at the parameter, at the command line. So the way this originally worked was I type this, I'd say get instance minus computer name, blah, minus use SSL, true, minus session options equals this, minus credentials equals that. And you can see that that line gets pretty long, 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 long. Well, instead, you just put it into a hash table and splat it. Okay? I just love that name. Okay? So now, we'll call that thing, asking for the operating system from my Unix box, and I'll format that as a list. And there you go. Now we're talking to a Unix box. Here, let's find out about its disks. See, we have 2 disks. We can get information about its processes. We can now, again, just XML, so we'll sort it, format it. Okay. So here we're showing the priorities of the processes, the handle, the name, where they came from. And if you're a Unix geek like I used to be, we'll hit this. We'll get all this information. What we're going to do is we're going to sort it by the parent process ID and then the handle, and then we'll output it grouped by parent process ID. Okay? So as you would expect, process ID 0 is init. Everybody who knows Unix know that init is the parent of these set of processes. And then these set of processes are parented by this. So what's that? 2273. HAL-D. I don't know what HAL-D is, but it's got these things. Oh, it makes sense. HAL-D add-ons. Okay? So it's incredibly powerful stuff. And fun. All right. Now, there's fine grain of control on this stuff. I mean, it's one of the advantages of an ecosystem, right? We do all the heavy lifting. You plug into us, we do all the heavy lifting. So with this web service management stuff, there's a ton of options. But here are 3 I just want to kind of highlight, right? So you're here and you want to talk to some machine in the cloud. Well, what if there's a proxy in between, right? Do you even think about that? Like, how do you deal with that? How are you going to find it? And then, what if the proxy requires a different set of credentials than the endpoint? And so using WS Management, we've plumbed all that infrastructure. We can auto-detect the proxies, different ways to detect them, decide what the authentication mechanism to the proxy is, and even provide credentials to the proxy. So let me get that in focus. I want to go from this machine to that machine in the cloud, but I've got to go through a proxy in between. And you're able to say, here's a set of credentials I want to use on the end machine, here's a set of credentials I want to use on the proxy, and here's how you find the proxy. And you don't have to code any of that. We do all that heavy lifting for you. Now, when it comes to talking to a single machine, there's a number of ways to do it. You can use remote WMI. So if the device does not have PowerShell on it, that's not a problem. You can use WMI to talk to it. And you see in version 1, I think we did a pretty good job with WMI. In version 2, man, we just blow the doors off. We did a great job in the support of WMI. Well, we think we did. You'll tell us. But I'm very happy with it. Then, if you put PowerShell on there, you can do more stuff. You can do remote command execution, remote script execution. You can do background jobs. You can have remote interactive sessions. And then we can use bits. That doesn't require PowerShell, but you can also do bits. Okay, let's talk about bits first, because I'm not going to show it, but I do want to talk about it. Bits is the binary intelligent transfer service. How many people are using bits today? Okay, not enough hands. You guys all need to get bits in focus. This is just an awesome protocol. Whenever you have like large data sets that you need to get from here to there, this is the protocol you want to be using. Okay, so you say I want to do this. It runs in the background and it's intelligent. That's why we call it bits. It'll be it utilizes the appropriate. It's bandwidth appropriate or network appropriate. It monitors your bandwidth utilization and will throttle itself to make sure you don't interfere with interactive jobs. Admins can schedule it to say, hey, during this time of the day, it can use this percentage of the network. After hours, it can use 100%. You have prioritized transfers. You can do caching. Everybody here needs to get some service pack. Well, the first person that brings it down gets it there, and then we all bash the hell out of their machine. No, it gets distributed around so you don't abuse the network. Very good stuff. But the key part, the key reason why you really want this is you start, that was bad. You start a transfer and then you have a network partition. It says, yeah, whatever. Text that, keeps on going. You reboot your machine, comes back up, continues where you were. End machine shuts down, that's fine. Just notices it, waits. When it comes back up, it resumes. So it's very good about that stuff. And of course, it uses HTTP, HTTPS, or SMB to do this. This is the protocol that makes Windows Update possible. I don't know if you ever thought about that, right? Next time you go and you get one of those updates, like update, and you see this like monster service pack, like, hello, welcome to this 200 megabyte service pack, right? And you say, oh my God, okay, fine, click it, go play with the kids for the afternoon. Well, think about it. Everybody in the planet is doing the same thing. So how does that work, right? And the answer is bits. Bits is the special sauce that makes that possible, okay? So y'all ought to get that in focus. Well, by the way, in PowerShell version 2, we've got a full suite of bits commands. So now you can, in your scripts, you can do bits. So let's get managing a single machine in focus. Okay, so we can use getWMI to get any of the WMI classes, right? You've been able to do this for a while. You get the BIOS information. And notice now it's nice and easy. You can have aliases, get GWMI, CN, and use positional parameters. And the great thing about our command is that you can take any WCL. Has anybody ever used WQL? Yeah? Oh my God, tough stuff, right? It's great stuff, it's powerful stuff, but like trying to get the query right is difficult. So now what you can do is you can go to the web, do your favorite search engine, grab any WQL and just paste it into this command and it'll work, right? So here's kind of gnarly thing. Select star from meta underclass where underbar this is a blah. You just cut, paste, happy, happy. Okay? So that's what you could do in version 1. But in version 2, we dramatically improved the experience. So first, there's a full set of WMI commandlets. Next, we've now improved discovery of WMI. Oh my heavens, this is great, right? So here, somebody once said that they had a love-hate relationship with WMI. I said, really? What do you love about it? And they said, anything you want to know about the system, you can get from WMI. I said, yeah, well, sure, but then why do you hate it? I said, we can't find any of it. Okay. Well, here what I did was I said, list me all the classes that have the name account in it. And here, now it finds that, right? So wildcards. Now what we can do is we'll do the same thing, but we'll do recursive. Okay? So it'll walk the namespaces looking for classes that have the name account in it. Okay? Now, what that did was it started in the default namespace. The default namespace is root simv2. Here what I'm going to do is I'm going to start at the very top of the tree at the root namespace and do that recursive. That's going to take a long time. So what I'm going to do is I'm going to say run that minus as job. So I run it in the background. And we'll check on that thing later. But here, see, it's running in the background on that machine. We'll get that later. Now you can also monitor events on a remote WMI machine. Here's a script which does a WMI query looking for events for services that have stopped. Okay? So first I'm going to make sure that the service I have is running, the ALG service. I have no idea what that thing does, so I don't mind stopping it. And what I'm going to do is now monitor that thing on a particular server. Okay? So it's now running. Now it shows me get event subscriber. It shows that I've got a WMI listener listening for that subscription. And now what I'm going to do is I'm going to stop that service. And the way the WMI stuff works is it actually does synthetic event generation. Okay? So what's actually doing is it's every 2 seconds grabs that list, looks for deltas, and generates an event, synthesizes an event. So now I'll get the event. It's happened. When you take a look at this, notice it gives you the previous instance and the target instance. The point of that is, we'll take a look at the target instance. We'll see that ALG stopped. Okay? So you can use WMI eventing to monitor the status of particular machines, monitor events of machines. Now let's take a look at remote script invocation. Here, you can do this in version 1. You can say invoke command give squiggle brackets, and run a command. And here you can run anything, a command, an expression, a command sequence. So you could do that before, right? That's my machine. But now, and here I'll alias this, ICM, invoke command, get all the services that begin with S, right? And here, again, you can do anything. So again, this is all running on version 1 stuff you can do on this machine. So here it's a full expression, command sequence. Okay? But now in version 2, all I do is I say minus computer name. Use exactly the same syntax, but I add an additional parameter. I say I'd like to run this code, but I want to run it on that machine. And now this takes a while because what we're going to do is we're going to go over there, start up a process, load the CLR, initialize PowerShell, run the command, get the results back. I probably should have made sure WinRM was running. Oh, it is. There you go. So it took a while, right? So we don't want to do that. So what we're going to do is we're going to create a connection, and then we're going to create a connection, a PS session. We give the credentials and the user, and now let's see how we're going to do exactly the same thing, but now look how fast it runs. Okay? So you amortize that connection cost over things. So I also, when I ran that, I saved the results in SV. Now notice, here when I run this, get the services, I see these things, status name, display name. But when I run it remotely, notice that we add the origin information. Where did that data come from? Okay? So here, I stored the variables in SV. And when it comes back, notice its data type. It is not a system service controller. It is a deserialized system service controller, okay? But it's still an object, right? I can do all that good stuff to it, right? So it's still an object. Here, I'm going to set a variable, remote code, and this is actual code, right? Get service, blah, blah, blah. That variable is now, contains code. And what I can do is I can say, I invoke command, and I give the code, and I'll run that code on the remote machine, and I get the objects back, and then I continue to operate with things. So I'll say sort it by can shut down and format it here. And the point I want to highlight is that the mechanisms we provided you in version 2 give you a fine degree of control over where you run which code. The reason why that's important is it allows you to be flexible and agile with respect to the operational characteristics of your environment. What the hell does that mean? That means if you got a wide area network or you're working across a slow link, you could say, hey, I want to take advantage of that and maybe not have my for loop here. Maybe I put the for loop over there. And when I return the data, if it's on a LAN, maybe I return all the data because that gives me maximal flexibility. But if I'm going across the ocean, across a wide area network, maybe I select the data elements that I want, the ones that I know that I need, and just pick those up. So you have full control over that. Now let's check, remember I did that background job? Let's check to see the status of that. We see that it's got data and it's completed. So we receive the job, and notice I say minus keep, okay? So here's what I did was I did a recursive directory of WMI looking for all the accounts, and so here it finds them all. I guess it was user, I found them all. And notice that I said keep. By saying keep, I ask for the data, but I don't pull it off the queue. It's still on that queue. So when I go and I receive it again, I'll get the data. Notice this time I don't say keep, so I'll get the data and remove it from the queue. And I'll prove that by asking for it again, and it'll say no. Now, just as we did that with WMI, you can do that with invoke command. So you see the pattern, invoke command, hostname, invoke command, hostname minus computer. Now we're going to say that minus as job. I'm going to do something, and I give it a name, as job, and I give it a job name. I'll wait for that thing to be done. It's done. I receive the information. I get it back. And now Now check this out. Here I am. I've got process ID. I'm going to show what my process ID is. And then what was I doing? It was $S. So the session was $S. That's my connection to the machine. So here I want to point out that this current process is 6340. Now what I can say is enter PS session $S. And notice my prompt changes. It says localhost. I've now got a secure, remote, interactive session on that machine, right? So when I run GPS, I do all this stuff. And when I say $PID, it's that. I say exit, $PID. Okay, so they're different processes. We have the remote, and when I did exit, I didn't disconnect, right? What I did was, it's still there. I just exited that interactive session. So you still have connection to that remote machine. Okay, so that's all about managing one device. Managing sets of devices is really quite a simple extension from there. Okay? With WMI, we have 3 parameters, minus computer name. Notice that it takes an array of strings. Okay? It has throttle. So you can say, I'd like to perform this WMI operation on these 5 machines, these 50 machines, these 500 machines, these 5,000 machines. Now, if you do it on 5,000 machines, chances are you don't want to have 5,000 requests on the fly. So we have this idea of throttle. And you can say, I'd like to do this to 5,000 machines, and I'd like to have 64 on the wire at any given time. And the way we do that is we'll set up 3 queues. To do, 5,000 elements, in progress, 64, and done. And what we'll do is we'll take 64, we'll issue those requests, and as one of them's done, we put it in the done queue, grab the next one, put it in. So it provides a sliding window of operations. Now this is really, really, really important and significant. We once worked with the MSIT guys who did a lot of WMI scripting, right? And they had a script that went to all their servers and got some WMI inventory information to produce a report. And, using VBScript. And because VBScript was serial, you talk to this machine, then talk to that machine, talk to that machine, and they had so many servers that this script, they would start the second run of the script before the first run had finished because it took so long to run. And God help you if anything went wrong, something went wrong, it just fell on its face. Well, here now this becomes an easy task. You say, I'd like to do this on a large set of machines, 100 at a time, and it just goes through it. So here's an example of how you might do that. Get WMI, computer name, and you'd cat some file here and say throttle it by 64. And then select the server name, manufacturer, version. You can convert it to HTML and output it to a BIOS inventory. So it's as simple as that to do a BIOS inventory across a large set of machines. Now again, if you want to do that for 50, maybe 100 machines, this is perfectly fine. But if you're going to do it to 5,000 machines, then you want to have this other version. You do exactly the same thing, but you say minus as job. Now it's going to run in the background, because that might take a while. And then you wait until it's done, and then you do the receive job, and you can do exactly the same 2 lines of code to create an HTML inventory. Now, managing sets of machines, the invoke command, again, it can run expressions, commands, or syntax. It can run in the background with minus as job. It, too, takes computer name and an array of strings. Notice the consistency here. It's like architected, designed. Learn it once, apply it over and over and over again. You can provide these session options, which gives you the fine degree of control over your networking. You can use a configuration name. The notion here is that when you talk to the remote machines, you can configure environments that have more or less capabilities. Okay? And the way you access those is with a configuration name. You can give these sessions, and you can provide alternate credentials. Okay. Let me see where we're doing on time. We're going to zoom a little bit. This is the idea of saying we want to be able to expose different user experiences to different people. And frankly, that's best. I'll show it, and then I'll demo it. So imagine I've got 2 companies, right? I'm an admin, and I got 2 sets of customers. You guys are paying me $2 a day, $2 a month. You guys are paying me $20 a month. I want to give you different experiences. And even then, you might have users, and you might have some like beginning admins and super admins. Okay. So what I do is when I've got those various people coming up to my labs, I want to be able to give a unique experience to each one of them. And the way we do that is through PowerShell remoting and WS management. WS management in version 2 can be an extension, IIS extension module, and PowerShell can plug into that extension module. When you connect in, you can run a startup script. That startup script can tell who the person is and craft a custom environment for them. And then they see only those things, and it runs in an impersonated thread. Best scene. All right. Okay, so first, this is me, right? I'm super admin, and I'm going to come in. This is the website that I'm going to go to. It's going to be a sales database, and I create a connection to that thing. Right? I can give it the URL and my credentials. And now notice when I run get command, right? When I ran get command before, I got a lot of things. Notice I only see 10 commands, right? Just to get that in focus, if I run exactly the same thing, get command star, if I could spell it right. Get command, yeah, star. Here's what I see normally. Lots of stuff. So clearly, this is a constrained environment. You only see 10 things. And notice that because I'm super admin, I have access to this organization. So this is a capability that works across multiple organizations, but you're not going to be able to access their information. They're not going to be able to access your information. So when they run this command, you're going to see that you're not going to have that parameter. But because I'm God, I have it. Okay? So here I go and add, again, it's got organization name. Now I'll go ahead and add some organizations. So I say add an organization, Microsoft, with this admin. And I create another one for Contoso with a different admin. And now we're going to create a different environment. Okay? Now these guys are going to log into that machine. Okay, so get credentials for this first guy. So this is my first customer. He's going to connect to that sales DB using his credentials. And when he runs get command, notice he's only got 7. This other guy had 5. He's only got 7. And notice the one command, add sales rep, notice it doesn't have organization. Right? This guy, what was it? Add sales rep. He has organization name. When he has add sales rep, there's no organization name. So we're creating custom projections of commandlets. Why? It's the magic, right? Remember, what is a commandlet? A commandlet is a .NET class that you put attributes on. We extract that grammar, and what do? We party on it. We party on it. We project it as an API. We project it as a web service. We project it as a command line interface. And here what we do is we project it as a programmable object that the web service comes in and says, I'm going to give you the whole thing. Well, me, I get the whole thing. You, I'm going to take out a few parameters and I'm going to give it to you. You, I'm going to take out a couple, and this one I'm going to add some additional constraints and I'm going to give it to you. Okay? That's the magic. Okay? So, I showed you already that. Now, we'll try and do this. We'll add a sales rep. Happy, happy. But I'm sorry, I should have made this bigger. Sorry about that in the back. Trust me, everything I said was true. But now I'll try and add this sales rep, and I'll give it an organization, and it'll say no. Now the interesting thing about this is This is not a security error. You're not getting an access denied. You're getting a, what the hell are you talking about? This is a parse error. This is better than security. This is like, I don't even know what, you're not even going to be confirmed or denied. I'm not even going to deny you. It's just not metaphysically possible for you to ask that for that thing. Okay? Now, it allows you to create these custom environments. Okay? So now imagine, it's like, hey, you guys, you're giving me 20 bucks a month. You're pretty reputable. These guys, they're giving me $2 a month. They're pretty dodgy. In fact, some of you guys are troublemakers. So some of you are going to try and do this. Ooh, let's go delete all their stuff. And the answer is, of no surprise, no. Right? It's a custom environment. There is no delete command. You get only the commands that I give you. Then you say, oh, but you know what? I'm a clever guy. And this is PowerShell remoting. And in PowerShell, when I do that invoke command, I can give a command, an expression, or a program. So I'm going to be an evil guy. I'm going to do denial of service. How about this? Yeah? Good stuff? No. Can't do that. It's a restricted environment. And when you create the environment, you get to decide what things to give them and not give them. And here we said, this is restricted. You can't do that. All right. Let's get that. Okay, now, notice what I did in all these environments, right? Invoke command, I give the session name, I give squiggle brackets and all that. And I'll tell you that's great. I mean, it's powerful. Awesome stuff. But, it's kind of a pain in the butt too, right? Like, squiggle brackets. Notice there's no tab completion. I can't do tab completion because I don't know anything about those things. Well, boy, couldn't we do a little bit better there? Well, the answer is yes. Now notice I'm going to do get command, my local space, and I'm going to prove to you, metaphysical, beyond metaphysical doubt, metaphysical certitude, I do not have the add new word command. I ask for it, it says, what are you talking about? No such thing. I'll then go and try and get the get sales rep. I say, what are you talking about? No such thing. Does not exist on that machine. Exists in the cloud, not on this machine. Yet. So now what we're going to do is we're going to import from the session a set of commandlets. So I give my connection information, and I say those two commands, get sales rep and new org, I'd like to import them. Oh. Now, when I say get command new org, I have it. When I ask for get sales rep, I have it. And now, when I say get sales rep, it runs. And if I get to give something, it asks for it. Notice it's prompting. It's a mandatory parameter. So it's prompting me, hey, what is it? It gives it. So how's that work? Boy, is that dangerous? Did I just inject code into my system? And the answer is no. We extract the grammar. So how's it work? You write the .NET object. In the cloud, we extract the grammar, allow you to manipulate it. You manipulate it, and we produce a proxy to it. And then I give you one proxy, I give you a different proxy. But then on this system, I go up to the cloud, and I extract the grammar of that proxy. And I create a proxy for it here. Now, the proxy here is a full proxy. And when I type the command, I have the command here. I do tab completion. I have help. I have formatting information, and when I hit carriage return, it just takes the request, sends it up to the cloud, runs it, gets the results, and outputs it here. It's like crazy. Now let's clean up. Now let me show you how that was done. This is the configuration. Okay, let's run a couple of these. Okay. This is the web config for that. What you see here is that WSMan is an IIS extension module, and that there's a plugin for PowerShell. And what you do is you give it an endpoint here, blah, 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 an endpoint. And what you say is, when they do that, I want to run this startup script. this startup script goes, it .NET's a set of this scripts, it .sources it, it's going to contain all the commands, all the new sales org and all that, and some helper routines. And so what we do is we get a set of commands, a generic collection, and we put in a set of commands that we're going to make available to everyone. So we're going to build up what is available to you and to you. Everybody gets get format data, out default, and select objects. So we add them all. Then here I get the sender information, and I do a switch on that sender. And I say if it's this guy, I'm going to add these commands. And if it's this guy, I'm going to add these commands. Okay? And now notice here, what this does is I create a proxy to those commands, and I add it. And here, when I create the proxy, I say -no organization. I say remove that parameter and omit it. These are the things that eliminate all the other commands and scripts, so you don't get anything except those. And then it takes the commands and says, if it's not one of the ones I gave you, make it private. So they're still there, right? So I can write a script. You can write a script that uses everything in the system. You have it access, but it's private. You can write it. The customer coming in from the web service can't. Okay? And then we have this notion of a language mode, and we set it to restricted language. Okay? That allows you to do some expressions, but not forever loops and things like that. So it's a safe, restricted language, and that's how you do it. It's as simple as that. All right, let's see how we're doing on time. Yeah, we've got a little bit of time. So I'll show you this example, and then we'll open up to some questions. In version 1, how many of you did tried to host PowerShell as an engine in your environment? Okay, so in version 1, the API, some people liked it, some people didn't. In version 2, we now have what's called a fluent API, so it's much easier to access. And here what I'll show you is also how to do this remotely, right? So open up a new project. Okay. So here's a main. We'll go ahead and get a password. This is where I'm going to connect to, the endpoint. The shell ID, right? So this is the endpoint, and this is, in WS Management, there's where you're talking to and then the resource that you're talking to. And all we do is we create a new WS Man connection, given the URI, the shell, the credentials. Run space factory, you create a run space, giving it the connection. You'd say open it. We now have PowerShell create. Now let's just walk through this. Okay. Okay, Lexus keyboard. So now what you notice here, what we did, we have PowerShell.add command. You give the command, and then you can say add parameter, and then you invoke it. Okay? That gets you a set of objects, and then we'll write object.properties name for each one, and you get that. Okay? So what I wanted to show now was the idea that said, to show you the experience of this API. So PowerShell, PowerShell.create. PowerShell.create. That returns a PowerShell object. Notice what I can do is add a command, get process. And notice it just sequenced. This is what's called a fluent API, where the API is designed to flow one to the other. I can add a parameter. Oh. Thank you. add a parameter, name, star SS. Now notice this. Now I can say add a parameter, add a command, sort object, dot, add a parameter, property, handles, and just so on and so on. Okay, so that's the new Fluent API. So back to the original question. When you're building a web service, and again, frankly, it works for enterprise too, you have to deal with these issues of how do I introduce great management on the fly cheaply? How do I deal with a wide range of administrators, the beginners to the experts? How do I automate operations for everything and to enable users to safely do their stuff? And surprise, surprise, the way you solve these problems is PowerShell version 2. Okay? So, got some time for Q&A, and if you want to use the microphone, great, but if not, I'll repeat the questions. Yes, sir?
Is there a way to write an Oslo DSL on top of stuff, or do you have some relationship interaction with Dublin?
Question is, can you write an Oslo DSL on top of this stuff, or what's the interaction with Dublin, et cetera? The whole notion of, I guess I didn't show it, but that restricted language, so the answer is no, not yet. Oslo's very early stuff, and we're about to ship. But we are building in the capability to do DSLs within PowerShell itself. So in fact, in PowerShell version 2, there's something called a data language. You say data and then open squiggle brackets, and you can only put things in that language which are safe, right? That can generate data. Then what you can do is you can say, in this data segment, here's a set of commands that I want to make available. And you see that as the building block tool to build your own DSLs.
Might be worth throwing quadrant on top of that then.
Might be worth throwing quadrant. Yep. Yes, sir.
Is it available on the Windows XP right now? Can I download it?
Is it available on Windows XP? So PowerShell version 1 is available today. It's been shipping for a couple of years. It's available on XP and above. PowerShell version 2, we've got a CTP out, works on XP and above. The remoting, however, doesn't. You'll get that in our next CTP that comes in December. And then this stuff is all in your pre-beta. Yes, sir. Can you write a Silverlight application to WSMan? So one can, but I can't. I just asked, in fact, this morning. I knew that question was going to come up, so I sent the mail to those. I could bring up my mail and see it and find out they answered it. But looking for a JavaScript example. But that's the whole point of WSMan, is that it is a standard protocol that anybody can access from anywhere. So I do not know whether someone has produced a JavaScript binding to it or not. But I'm going to try. When I find out the answer, I'm going to put it on my blog. If you haven't found our team blog, it's blogs.msdn.com/PowerShell, and we put lots of great information in there. Yes, sir.
Heather, I guess does or will Hyper-V support WSMan?
Does or will Hyper-V support WSMan? Yes and no. Yes, WSMan, no, Hyper-V doesn't know anything about WSMan, but Hyper-V knows all about WMI, and there's a WSMan to WMI bridge. In fact, that's what WSMan's all about, is accessing SIM data. So, yes. Yes, sir.
Can PowerShell access SOAP objects?
Can PowerShell access SOAP objects? I like this guy. Let's see. Where the heck was it? Darn. Well, let me just show you this. So in PowerShell version 2, we now have a new commandlet called new web service proxy. And what you do is you pass it a URI, and we'll generate a web service proxy on the fly that you can then program against. Yeah. Yeah, that's back to that thing about we want to be able to access anything. You might have asked, how do you access unmanaged code? And the answer is, when you see PowerShell version 2, you'll see that we have the ability to embed C#, VB, F#, any .NET language in your PowerShell script. And then we'll compile it on the fly and execute it. Now you might ask yourself, that's odd, why did you do that? There's a zillion answers, but the two big ones is a place called pinvoke.net. Pinvoke.net is a website that you go and admins need to be able to access anything. A bunch of the stuff they need is still only available in unmanaged code APIs. Pinvoke.net is a website that shows you for each unmanaged code API how to get at it with C#. So now all you have to do is you go there, you cut and paste that C# into your PowerShell script, and now PowerShell can access that through your C# code. That's one reason we did it. The second reason we did it was if you have you want to write this nice big PowerShell script, but at the inner core of it, you're going to walk through a terabyte of data, some monster log files. There, because we're reflection based, there's performance limits to what we're going to be able to do. So instead of saying, oh, it's just inappropriate, you can just take that inner loop of that big script and say, this thing optimized for performance, I'm going to write it in C#. That's why we added that. Yes, sir?
Are there plans to add PowerShell to Visual Studio?
Are there plans to add PowerShell to Visual Studio? There are dreams, but not plans. We had an intern. We had an intern do it. It's always a struggle at Microsoft to figure out, everybody wants to move the ball forward the fastest, the most, and you have limited calories you can spend. So you're always trying to figure it out what it was. It was very clear the most important thing we could do was to nail this remoting. And we think we just, I don't know, you tell us, but we're very, very, very pleased with how the remoting came out. Now, I will tell you, there's one part I wasn't so pleased on. That you can reuse the session, and then it's really, really quick. But that initial startup is a little bit expensive. And the reason for that is it's a protocol issue that we're going to get fixed. I'm going to bet somebody's job we get fixed by the time we ship it. It's basically that the protocol is very rich. You can, in fact, transfer secure strings across the protocol. But what that means is you have to have a key exchange to do that. And we do the key exchange on the startup. That's the reason why it takes so long. But the real answer is most of the times you're not going to do a secure string transfer. So you should defer that key exchange until it occurs. And when we get that, man, we're just going to be fast, fast, fast. I forgot your question, but I hope I answered it. Say again? Oh, yeah. So will start time for PowerShell be better? So here's the thing. Anybody says what a glorious thing declarative programming is, you just take that stuff with a grain of salt. Let me tell you a story about declarative programming. Turns out that our setup is declarative programming. You declare a set of things. Well, there's all sorts of hidden semantics behind that were not obvious. I mean, not obvious to my guy at least. And it turns out that when we declared things, we declared them in a way that they did not get engined. Right? Ngen is the process of taking your executable and jitting it so it makes it really fast. And so it didn't get engined. And so it's slow as heck when first time you start it up. One, we fixed that, so that's a lot faster. Two, CLR got a lot faster at cold starts. Three, we improved our startup stuff, so it should be a lot faster. But you do not have to suffer in silence. You can go up to you just search for my name, Snover, and fast, or better yet, update-gac. And there's 3 lines of code. You cut, you paste it into your PowerShell version 1, and all your users are just going to be they're just going to smile. It's so much faster. So yeah. Yes, sir. Yeah, the question is there any changes in the way you can access the pipeline objects? So you can access the current one, but you can't access the first one? There aren't, but we haven't heard any requests for that. So here's the thing. If you write that up, what you think you'd like, I don't have that need in focus. So if you can clarify that need in an email or something, that'd be great. Yeah. Again, if you could write that up, that'd be great, because then we could evaluate it. Great. Yes, sir.
CTP, you mentioned in December, is that WinRM only, or is that also for PowerShell?
So it is two separate CTPs, and that's something we'll be fixing over time. So right now, you have to have a WinRM. So CTP, is that just WinRM, or is that PowerShell as well? Answer is both. You're going to have to get the WinRM stuff, install that, and then get the PowerShell stuff and install that. And you'll see going forward, we're going to get rid of all that nonsense, and there's going to be a management platform redist, or management platform download that'll contain all the stuff that you want, right? Here, you want to hear a scary fact? Hey, I got this WinRM stuff, I got that PowerShell stuff, I got that bit stuff, I got something else. Can I like take that stuff and put it on my system and have it work? Answer is, I don't know. You tell me. Nobody's tested it. You know, the answer is it does work. But there was nobody whose job it was who's takes out their badge and says, I guarantee that stuff all works. It's just crazy. So we're fixing that. And then the teams had different visions of down level. Well, I'm going to latest version only. Well, I'm going to go back one version. Well, I'm going to go back two versions. Just craziness. So we're going to fix that for you. There'll be one download, same policies. I don't even know if they have the same licenses or not. They probably do, but I don't know. One download, you're going to know it's the same license. By the way, I didn't mention one of my favorite features. In PowerShell version 2, that you can write, well, I mentioned it, you can write PowerShell commands in PowerShell script itself. That's just incredibly powerful, because in the past, users can only generate functions, which are not as powerful and does not give you the agility that and power that a commandlet does. And now you can do this very, very quickly. That is the secret sauce that allowed us to go up to the cloud, grab the data, and what we emit is a script commandlet that was emitted doing that. And so it allows all sorts of metadata programming things that are just psychotically powerful, right? You'd be able to do things like write a program that goes against the WMI classes, reflect that information, and then emit commandlets to access that stuff. It's freakishly powerful. Yes, sir?
If you have a transcript right now and for long-time tools, you don't see the output of the tools of transcript. Is there any transcript in
If you run transcript, and you run an existing executable, that output of that executable is not included in the transcript. Is that going to get better? Sadly, no. That's just one of those things that we have to go back and rewrite those commandlets so that what they're doing is they're calling the console APIs, and it's like, man, if there's a way I could get them, I would, but there's no way to get at them. Now, honestly, I could write a ton of code, I think I could go and try and detect whether they did that, and then write a screen scraping program and make it modal, blah, blah, blah. But honestly, if I wrote that code, I wouldn't have been able to do this code, so it doesn't look like a good investment to me. I think a better investment is to get those guys to rewrite. Yeah.
Are there any plans for PowerShell compiler that compiles executable?
Are there any plans for PowerShell compiler? Well, in fact, we have a bunch of PowerShell compilers right now. What happens is it's like little peephole optimizations. It's one of the reasons why the performance of PowerShell version 2 is quite significantly faster, the runtime performance, than PowerShell version 1. And one of the reasons for that is that we do these peephole optimizations where various times we'll go and basically compile a little section of code. So the first time you run it, we compile it, and then we execute that compiled code. But in terms of like a big overall compilation step, that's not currently in, not yet. Keith?
Yeah, do you think we'll see V2 before Win 7 ships?
Oh, I can answer that one. Will we see V2 before Win 7 ships? Not with me staying at the company. not with me keeping my job. No, this will ship in Windows 7 first, and Sanofsky just nailed that, right? When's Windows 7 ships? You'll tell us, right? This is what I call headlight scheduling. When you drive your car, your headlights do not illuminate the path to your destination. They illuminate the path for the next 30 or 40 feet. And then you get there, and then the headlights illuminate the next 30 or 40 feet. That's the scheduling model. So you know what? When's the end game? I don't know. I know what the game to beta is. And when I get to beta, I'll know what the game to RC is. When we get to RC, I'll know the... So it's headlight scheduling. We don't know when it's going to come out. But then shortly after that, we'll have the down-level release. Yes, sir?
Yeah, will there be a PowerShell provider for Windows Asia?
Oh, will there be a PowerShell provider for Windows Asia? In the keynote, they actually showed one for the storage stuff. And then I saw a blog of someone who had done one for the SSD, I forget what the name of that was, the structured storage devices. So yeah, if you get the Asia SDK, there's one in there now. Yeah. Excellent. Well, thank you very much for your time. I hope it was valuable. I hope you grab PowerShell version 2. The one thing I do want to highlight is the way the process is run. We're now at a stage where user requests can be acted upon, and internal, like I think this is a good idea, we can't. And that window is going to close. So grab the pre-beta stuff. Bash the heck out of it. If you see something that's a little bit quirky or odd, don't just say, oh, I wonder if that's quirky or odd. I wonder if they'll pick that up and fix it by the time I ship. Don't do that. Complain. Go up to Connect and file a bug, vote on your favorite bugs. It empowers us to get you the changes you need. Right? Get that in focus? You complaining empowers us to do the right thing. So complain early, complain often. Thank you very much.